All right, first review day here. We're going to start with some trigonometry. Okay, right triangles here. We have the hypotenuse. From this angle A, if you look across, that's the opposite side. And this side over here, the leftover, is the adjacent side, right? And we have some old horse caught another horse taking oats away, or SOHCAHTOA. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over adjacent. Okay? Down here we have the reciprocal identities, which these are new for you this year, remember. Cosecant is equal to 1 over the sine of A. And the secant is 1 over the cosine of A. And those of you with a handout, I apologize, that's been turned upside down by somebody that will be named later. 1 over tangent of A. So that's what the reciprocal identities. So if they're reciprocal identities, they're going to be the reciprocal. So if sine is O over H, cosecant is H over O, right? And this one's H over A, and this one is adjacent over opposite, okay? So you can use those, okay? Quotient identities. The tangent is equal to the sine of A over the cosine of A. And the cotangent is equal to the cosine of A over the sine of A. All right? So that's the reciprocal identities, the quotient identities, and right triangle trig. Cofunctions we talked about a little bit here. And basically, if we go back up and look at this triangle I have here, right? Let's say the sine of A. The sine of A is opposite over hypotenuse, which is like BC over BA. Well, you know, the cosine of angle B here is actually BC over BA as well. And the relationship between A and B in a right triangle is, well, B equals 90 minus A. So with cofunctions, if that is A, the sine of A equals the cosine of 90 minus A. And the secant of A is the cosecant of 90 minus A. And the tangent of A is the cotangent of 90 minus A. Okay? So we have those cofunctions, and you can solve those like that. I'm moving really quickly because this is just review, basically, you know, kind of refresh your memory about this stuff, and then we're going to do a lot of the examples in class tomorrow. All right, with the unit circle. Now remember, this is a unit circle, so the radius of this is always 1, okay? And if I kind of draw this reference triangle here, okay, the sine of theta is this side over 1, right? Which, that is the y-coordinate here, all right? So the y-coordinate of any point on the unit circle is sine theta. And the x-coordinate of any point on the unit circle is the cosine of theta, okay? This is the x, this is the y, it's x over 1 or cosine theta over 1, okay? All right, so that's that. Special angles. Now, if it says to find the exact value of, or if it says in simplest radical form, this is when you're not going to want to use the calculator to evaluate trig functions. You're going to use like these special angles. For like a 0-degree angle, I'm going to use what I know about the unit circle. That's cosine comma sine. And this point right here is the point 1, 0. So the cosine of 0 is 1. The sine of 0 is 0. And remember, the tangent is sine over cosine, so that's 0 over 1. So the tangent of 0 is 0. All right, and then at this point right here, right, this was 0 comma 1. This point right here was negative 1, 0. And this one down here is 0, negative 1. So if I asked you to find like the cosine of 270, all right, there it is. It's a 270-degree angle. The cosine of 270 is equal to 0. Okay? That's kind of the examples that we would have with that. Now to find a 45-degree angle, I'll use my special right triangle, my 45, 45, 90. All right, and each one of these angles is 45 degrees. Remember that? And the sides of that are 1, 1, radical 2. So if I wanted to find, like, for example, the sine of 45, it's 1 over radical 2. You rationalize it, it's radical 2 over 2. All right? And to find 30 and 60, I'm going to use a 30, 60, 90 triangle. The littlest angle here is 30. This angle is 60. And 1 is the shortest side, 2 is the longest side, and radical 3. Okay? So for example, the cosine of 60 is 1/2. The sine of 60 is radical 3/2, and so on. You can use these right here. You can use these and the special triangles to find the exact value of all kinds of things. All right, so evaluating with reference triangles. And what happens here is I have to keep in mind what's positive in which quadrant. And I always remember, we always call that all-star trig class. So they're all positive in the first quadrant, just sine is positive in the second quadrant. In the third quadrant, tangent is positive, and in the fourth quadrant, cosine is positive. Now remember, the reciprocals are going to be positive there too. So if it says cosecant is greater than 0, and the cosine is less than 0, that means it's in this quadrant over here, because cosecant is the same as sine. It'll be either positive or negative, just like sine will. All right? Now, reference triangles. If I wanted to find the sine of 300, what I do is I draw a 300-degree angle in standard position, which is going to come around down here into the fourth quadrant. Okay? I draw my reference triangle. My reference angle there, if this is 300, and this is alpha, my alpha equals 60. So, all-star trig class for that. I'm doing the sine of 300. Sine is negative in that quadrant, so it equals the negative sine of 60. And then I use my special triangle for the sine of 60, which is radical 3/2, negative radical 3/2. Okay. Moving on. Next page. All right, so if I want to convert something from radians to degrees, I'm going to multiply by 180 over pi, okay? So if I want to take like something like 2 pi and convert that into degrees, I do not do this. Because I see this sometimes, and then kids start cross-multiplying. No, okay? That's not what I want to do. I want to multiply by 180 over pi. So I take 2 pi times 180 over pi. Then I can cancel the pi's. 2 times 180 is 360 degrees, okay? So just be careful of that. Make sure that you're not setting it equal to 180 over pi. You're multiplying by 180 over pi. And then if you're trying to change degrees to radians, like well, here's the example, convert 45 degrees. I'm going to take 45 and multiply that by pi over 180, just like that. All right, and then I'm going to reduce it if I can. 45 goes into 45 once, and it goes into 180 4 times. That equals pi over 4. All right. A mistake a lot of kids will make, 4.23. They'll put a pi on there because they think pi is the unit for radians. It's not. It's not a symbol for radians. That is 4.23. All right. I don't know what that is equal with a pi in it, but to change it from radians to pi, to degrees, I multiply by 180 and then divide it by pi. And the best way to do that is with a calculator, right? Obviously, I take 4.23 times 180, enter, and then I divide by pi, right? And then I get it, whatever it says to round it to, 242.4 degrees. Okay, so that's how you convert something from radians to degrees. And we usually work pretty much in degrees in this class, so if they give you something in radians, go ahead and change it to degrees, okay? And then work with it. Unless you're doing arc length, okay? Arc length must be in radians, okay? So that's the first thing you need to say. Must be in radians. Okay, and the formula for arc length is S equals R theta. That is not on your formula sheet. You need to memorize that. R obviously is the radius. The S is the arc length, the length of the arc that's intercepted. And then theta is the central angle in radians. Okay, make sure it is in radians. Okay, so for the example here, find the measure of the radius of a circle if an angle of 300 intercepts an arc of 50 centimeters. So like a 300 degree central angle, so this is like 300 degrees, what I have to do is I have to change that to radians, okay? So S equals R theta, and they want me to find the radius when the arc is 50. So 50 goes in for the S, the R I don't know. I cannot put 300 here, okay? I need to take 300 and change that into radians, all right? 300 times pi over 180, just like that, and then you can reduce it, right? And remember the trick to reduce 300 over 180, 300 divided by 180, enter, and then if you hit math and then frac, it'll turn it into 5 pi over 3. Okay, so that's 5 pi over 3. So I'm going to multiply by 3 and then divide by 5 pi. All right, and so I have 150 over 5 pi. I guess you can reduce 150 over 5 and say 30 over pi. If it wants it to the nearest tenth, then you just take and do 30 divided by pi on your calculator. Okay, all right. Degrees, minutes, seconds. What you want to do here is you want to convert a decimal degree answer into the nearest minute, perhaps. Like so what is 23.45 degrees to the nearest minute? They ask you to find an answer to the nearest minute or nearest 10 minutes. You need to be able to convert that decimal into minutes. All right. So without the calculator, I'm going to keep the 23 degrees, but that's 45 hundredths. I don't want to turn it into hundredths. I want to turn it into 60ths because there are 60 minutes in a degree, all right? And then you just cross multiply there. So it's going to be 45 times 60 and then divide by 100. 45 times 60, all right? And then you just divide that by 100, all right? And then round it to the nearest minute. This one didn't need to be rounded, so my x came out to be 27. So what is that? That is 23 degrees and 27 minutes. And the minute sign is just like a foot sign. Okay, that's the symbol for a foot. Now, if I want to do this on my calculator, I can take 23.45 and under angle, which is second apps, there is convert to degree, minute, second. So you see that it's choice 4 here. And that turns it into 23 degrees, 27 minutes, and 0 seconds. Okay, when you are rounding to the nearest minute, okay, you round 30 or more goes up, all right? So because it's halfway isn't like going to be 5 or more, it's going to be 30 or more because there's 30 seconds, there's 60 seconds in every minute, okay? So either way, you can do it with the calculator or without. So if I want to find the sine of 34 degrees, 15 minutes, I have a couple choices here. I can take the 15 minutes and turn that into a decimal by doing 15 divided by 60 and say that's 0.25. And then I can do, make sure I'm in the right mode here. I am, degree mode, right? Okay. I can take and do sine 34.25 will give me the answer. Or you can put these in using that, right? Sine 34. And then if you go under the angle again, there's a degree there, so it's 34 degrees. And then I can put in 15. And I go back to my angle menu here, and there's my minute symbol. All right, close the parenthesis, and you're going to see it's going to give me the same answer. Okay, so it is what? 0.5628. Okay. Either way, either use the second angle or change it to a decimal and do it that way. All right, angle, sum, and difference. Those are on the formula sheet, okay? And I'll have you kind of look those up. But sine of A plus B, we'll do that one because that's the one I need for this. It's going to be sine of A times the cosine of B plus the cosine of A times the sine of B, okay? And then the rest are similar. You can kind of look them up. You don't have to memorize them because they're on your formula sheet. Find the exact value of sine of 75. I'm actually doing the sine of 30 plus 45, which is going to be sine 30 times the cosine of 45 plus the cosine 30 times the sine of 45. And